Hello friends, welcome back to my YouTube channel. In previous video of concept of machine learning tutorial series, I will discuss about linear regression. In this video, I will discuss about optimizing using gradient descent method. So let's start. What is gradient descent method? This is an machine learning optimizing algorithm for machine learning and deep learning program. Before starting this, we have to revise some mathematics concepts, that is concave and convex function. So what is concave function or convex function? Suppose this is a graph gx, this x and gx, this is y equal to gx. Now any 2 points in this curve, a for a ga and other point b gb, and if we join these 2 points ga and gb, we will get a straight line which is always lies below the curve. Suppose this or this or this. For every any straight line between if we join 2 points on the curve, then the straight line be always below the curve. This is concave function. In converse, for this case, if we take 2 points A and B, and then line joining between line joining by 2 points GA and GB always lies above the curve. This is convex function. Now maxima and minima. Maxima. Suppose this is a point A, this is A plus E, and this point is A minus E. Suppose these 2 points very close to A, very close, that means E tends to 0, then A always greater than A plus E and A greater than A minus E. This is concept of maxima. To read it more details and clearly, view my blog, link in description. This is point A, this is point E, this is point E. E tends to 0 for minima. A plus E less than A less than A plus E and A less than A minus E. Then and at point A minima arise, and this portion is for maximum. But suppose this curve is neither concave nor convex, because any 2 points joining the curve here below the curve and here above the curve, so no concave, no convex. in this PPT there is a wrong thing. There is also a wrong. This is here is maxima and here is also minima. Here neither concave nor convex, but this is neither concave not convex. Please visit my blog. In PPT some wrong. In my blog it is written in correct way. Link of the blog in description. Now finding maxima minima by hill climbing method. Suppose I am changing my color. This is a point. Okay. Here is not maxima nor minima. So to find minima we have to go here, then here, then here, then here. From this point here, 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 and this is minima. Okay. Now how to find this minima? So what we do, xt plus 1 equal to xt in df by dt. Xt means at time t, sorry, at time t, and minus n into df by dt. Yes. So this is negative, this term negative, and this is also negative. So this negative and negative, this is positive. Okay. So xt equal to xt plus 1 equal at t plus 1 time point is here and at t here. So xt plus 1 equal to xt minus n df by dt. That means suppose df by dt equal to minus 2, because because df by dt negative, so we are taking minus. Okay, minus 2 and n equal to suppose 1. So xt equal to so xt plus 1 equal to xt plus 2. Okay. Similarly, this point come here, here, and 0, and finally at minimum point. This is the concept of gradient descent. Finding minima by finding minima by hill climbing method. In this point, df by dt positive, and n is negative. N is positive always. N is a constant value, and df by dt positive. Suppose df by dt equal to 2, and n equal to 1. So xt equal to xt plus 1 equal to xt minus 2. Okay, xt minus 2. If so, at t plus t time, at time t, point is here, x at t plus 1 point is here. So so it is descending from here to here. Okay, this is the concept of finding minima by hill climbing method, and this is gradient descent also. While not uh, here, while not converge, xt plus 1 equal to, here xt plus 1 df by dt is positive, and if suppose point is here at t time, at t plus 1 time, suppose n equal to 2 and df by dt equal to 3. So at xt plus 1, value will be xt plus 1 equal to xt plus 1 equal to xt plus 6. That means it is climbing up. In this way, climbing up. And similarly, you can think how the point come from here to here to here to here. This is the concept of uh, finding maxima by hill climbing method. Now choice of n. If n is too small, suppose n is too small, then gradient descent is very slow, and if too large, mm, then point here to here, then here, then here, then here, uh, which escape minima. So you can't find minima, and maybe it become infinite loop. So what to do? We have to choose correct n, value of n. This is this n equal to alpha, where alpha is a constant, divided by t. This is the correct choice of n. Convergence criteria is df by dx equal to 0, because at minima or maxima, if it is fx, then at minima at minima df by dx equal to 0 at minima, and at minima maxima also df by dx equal to 0. So convergence criteria is df by dx equal to 0, but in real practice uh, it cannot be 0, because it's maybe it, maybe it is correct choice for n, value of n, but it escape this minima point. Sorry, it escape this minima point. It escape the minima point. So we have to choose a threshold value, that is epsilon, and df by dx, its mod of df by dx is always less than epsilon naught, epsilon. Now gradient descent in machine learning. Suppose this is the equation j b0 by b0 b1 equal to b0 plus b1x. this curve is, if we plot b0 and b1 in this is b0 axis, this is b1 axis, and this is j b0 b1. Value of j is depends on b0 and b1 for constant x. Now what we do, we see it is the top view of j b0 b1. This is a point j1 b0 b1, j2 b2 b1 b2. For j1 b0 b1, it is the this is the curve is this. For j2 the curve is this. Now what is gradient? According to gradient descent algorithm, repeat until converge, that is bj equal to bj minus alpha delta b0 delta j b0 b1, it is j b0 b1 by bj, where j is 0 or 1. This is delta j b0 b1. This is a typing mistake. That means this point is at the center point best b0 and best the center point is best for best value of b0 and b1 in this situation, in this case. Now what is correct method? Suppose b0 is equal minor, we are for j0 j repeating until converge. See, j equal to 0 and 1, two value. So what is the correct method? b0 equal b0 equal to b0 minus, at first we store this value in temp value, then temp 1 this value in temp 1, then update b0 and b1, or update b0 and b1 after iteration. This method is wrong and this is correct method. Why? Because this method 1 is correct, method 2 is wrong. Why? Because let's see, b0 is change, here b0 is change, and in this point when you take differentiation, then you have here you differentiate j b0 b1 for new b0, but you have to work with old b0 value. So this is the correct method and this is the wrong. Now gradient of RSS. This is the gradient of RSS. Now how to find minima. There is two approach. At first set gradient equal to 0 and then solve it, find b0 and b1, or gradient descent. But in machine learning, b0 in practical machine learning problem, it is difficult. It is not possible somewhere that to set gradient equal to 0, and then you have to choose second this gradient descent approach. Now some important thing. Feature scaling. This is for unnormalized data and this is normalized data. What is unnormalized and normalized data and mean normalization? Suppose area price area, here is area of 1 square feet, price something 1 for 1 square feet, price of 1 square feet, and there is a house of 1000 square feet. If we here is a large difference between 1 and 1000. So when we plot gradient descent curve, this is become like this, and we have to descend like this, and it take very much time. So what we have to do, we have to use this curve. This is taking very much time, so we have to take this curve. So we have to take this curve. This takes very much time. Now how to convert this curve to this? To convert this to this, we have to use mean normalization. That is value minus average value of data set divided by maximum value minus minimum value. If you do this, then you will find this normalized curve. How to make sure that the gradient descent is working? You have if you see that JB is decreases after every iteration, then it means gradient descent is working. Okay, thanks for watching.